Hello everyone, and welcome back to my channel. This is Vishnu Anjipudi, and I'm glad that you're all here. Today, we will be solving LeetCode problem number 27, remove element. The problem reads, given an array nums and a value val, remove all instances of that value in place and return the new length. So, in place right here, as you can see, just means that it's an algorithm that changes the array itself without creating a new array. So it explicitly states here, do not allocate extra space for another array. So you have to modify the current array that you're given, which in this case is nums. The order of elements can be changed. It does not matter what you leave beyond the new length. So first, we should explain why it's returning an integer when it's actually checking for an array. So the way it works is you can replace values in the array and swap them in order to essentially remove these values. And this integer that you return is actually the length of the resulting array. So if you return, for example, in this array, if you return 2, it will just return the array 3, 2, and it will ignore these 2. So let's first begin. So we first want to create a variable that stores the length of this array, right? So let's call that length equals, we want it to be length. And what I was thinking is it starts out as the length of the original array, but each time you remove a value, you decrease that length by 1. Okay, and now we need a for loop. Okay, I is less than nums dot length I plus plus. So here we have to check if each element in the array is equal to val. So we're going to be using a for loop, and we can just say if nums I is equal to val. Now we want to push it to the back, right? It doesn't matter which ones are. So let's just push it back directly. So what I mean by this is if we do another for loop, so int j is equal to I, because you don't want to waste some memory and runtime. So int j is equal to I, j is less than nums dot length minus 1. You'll see why there's a minus 1 soon. So here, what we're probably going to do is we're going to just push it to the back of the array. So we have a constant, which is equal to nums j, and then we can set nums j equals nums j plus 1, and then nums j plus 1 equals k. So what this does is it just swaps the two elements adjacent to each other, which over time would essentially push it back to the end. And now we also have to subtract 1 from length, since that won't be part of the considered array. And then at the end of this, we return length. So let's see if this works. Run code. Wrong answer. So let's first print out length. And that should help us see what went wrong. So, it returns 0. Let's do it here. Oh, wait. We're keeping length in the for loop, right? Which means that it's going to be counted every single time we iterate the for loop. So instead, we can just put it outside the for loop so that problem doesn't happen again. Now if we run code, wrong answer again. We got 2. So let's see what went wrong. nums I equals val length minus minus. This system.out.print. Oh wait, I know why. We have to do a preliminary check because this is not necessarily the length, right? Because if you push the 3 to the back, then it's still going to be counted in the run length. So we first have to calculate length. I is less than nums.length I plus plus. And then we can calculate length separately, and then we just remove this and replace this with length. And then we just put if nums I equals val length my plus. Okay, now let's run this code. And it was accepted. Oh, wait, oops. Wrong answer. So for this one, didn't remove enough 2's. Oh, I get it now too. There's a problem when there's 2 consecutive numbers, right? Because if there are 2 consecutive numbers, then if you swap this one, then this one will become the previous one. So okay, and then we put and then this should, and then put while so this should help handle that second case. Okay, let's run it on the second test case. Not submit run code. Oops. Yeah, that's. So let's see. Wrong answer again. Oh. Yeah. Accepted. So let us submit. Runtime 0. We did it. Runtime 0 milliseconds, faster than 100% of Java online submissions. That's really good. We actually did a runtime 0. And memory usage, 37.8 megabytes, less than 5.05% of submissions. And we actually did it. We solved this problem with a runtime of 0 milliseconds. So I guess that's it for this video. Thank you all so much for watching. Also, please don't forget to like, share, and subscribe as always. And thank you for watching, and bye.